We'll do it again. So we're looking at number 6. Number 6. No, I'm not finding it. So number 6 is having us look at a contingency table and asks us to use StackCrunch to calculate the conditional distribution of the response variable. So the contingency table is found in StackCrunch in our group under Planning and Success in Community College Contingency Table. In order to do the contingency table, we're going to do stat tables contingency with summary. Our columns are degree or certificate, etc. So we pick all 3 columns, and our row labels are found in var 1 because I didn't name it anything. Now they ask us to, if we just do that, then we just get our table. There's nothing special about it. And we can get a p-value for chi-square. But what I want to do is go back, and we want to calculate the conditional distribution of the response variable, which is success. And the response variable success is in the columns. It's at the top of each column. That's where the success is. So I'm going to do a column percent and compute. And so for each column, you notice the bottom says 100% because it's done a percent for each one and then added them up. So it did 593 divided by 826, 64 divided by 826, 169 divided by 826. Does that look familiar? Mm-hmm. So when we went over it before, I talked about how there'd be a 1 at the bottom of each. So same thing, 26 divided by 53, 8 divided by 53, 19 divided by 53. So that's the column percent. And now it's asking the variable about planning, is that dependent on the success indicator? So are those things dependent? The planning, which was on our left column, and whether or not there was success. So that's when we go down to the p-value, which was 0.0002. So the p-value is less than alpha, which was 0.01. So we reject the null hypothesis. Oh, I said to determine the null and the alternative. Let me get that. So the null hypothesis always means nothing. So that means there is no correlation between the 2 variables. And the alternative says there is correlation. There is correlation between the 2 variables. Not correlation. The null is there independent. There's no dependence. There we go. And I'm trying to get my tablet together. I'm just unprepared tonight. So I was going to write on this, but now I can't find my tablet. Well, I have my tablet, but I don't have my writer. Oh, there it is. Okay. So in the case of chi-squared, my null hypothesis, why is this not working? Oh, there it is. Nothing's working for me tonight. Okay, my tablet's not working. Null hypothesis means there's no connection. So they are dependent upon each other, whereas the alternative is they're independent. So because the p-value is less than 0, then they're independent. Less than 0.01.
Because the p-value is what?
Less than 0.01, and that was alpha.
Okay.
So they're independent. That's our conclusion. Any questions?
So you're saying that the null hypothesis is there's no hypothesis and it's dependent on each other. But if it was H1, then it would be independent, right?
I'm going to go back to
I think I just confused myself by asking that question.
Yeah,
I'm gonna be quiet now.
that's okay. Okay. I'm going back to looking at it again. All right, I'm going to switch screens for you because I think I got that backwards. So I'm going back to the PowerPoint for chapter 12. Okay, and this is the key, that the null hypothesis says the variables are independent. The alternative is that they're dependent. So because our p-value was small, we reject the null, which means we reject that they're independent and say they are dependent. I think I said that backwards before.
It's okay. I get it now. I used that thing there for when I was doing the homework, so I know exactly what you're
Use
talking
this page, and that will be the key. Okay. So use this alternative, dependent, null, independent. So if we have a p-value that's smaller than alpha, then we can reject the null, and so the alternative is true. If we don't have a p-value that's small, then we can't reject the null and we can't make a statement about independence. Okay.
Which slide was that? Chapter 12?
It's chapter 12.
Slide 13.
Wow.
12:1, 12:2.
It's 12, chapter 12.
Section 1 and 2.
Sections 1 to 2.
Okay, thanks.
Slide
Oh, there it is.
13.
You're right. Slide 13. Look at that. Slide 13 out of 16.
Okay.
It's right there up by the arrows in the middle there, by the blue arrow in the middle.
Oh, thanks, Kate. I missed that. All right, right up here. 13 out of 16. Yeah, I would definitely keep that out because I would look it up just to be sure. Like I said, I don't have this stuff memorized yet. So, because I haven't taught it before. So when the p-value is less than alpha, we say that they're dependent. So in our case, it is dependent how successful you're going to be based on how much you plan ahead to go to college. Kind of makes sense.
Can I see what you had plugged in for StatCrunch for the problem, please?
You bet.
Thank you.
So here was what the data table is, planning and success in community colleges. And so you're going to put each of your 3 rows. So planned more than 6 months, 1 to 6 months, and less than 6 months. And then got a degree or certificate, completed at least 24 credits, completed less than 24 credits. And then these are the numbers that matched. So these are the numbers, these percents would go into part A, where you're looking to do the conditional distribution of the response variable, known as the column percent. So these percents would go there. And then null and alternative, as we said in the PowerPoint, p-value was 0.0002. So we reject the null hypothesis because it's less than alpha, which was 0.01. So our conclusion is they're dependent.